and today we are going to take a look how to use the leetcode efficiently. So, as an example, I would like to highlight the following problem, which is called perfect number. Let's try to read this problem description carefully. And it's about some positive integer that is equal to the sum of the positive dividers, excluding the number itself. A divisor of an integer x is an integer that can divide by x evenly. Given an integer n, return true if n is a perfect number, otherwise return false. Okay, so we are like really close to the first level of understanding for this one problem. And so what we probably should do, we should have some method for finding all the numbers, like all the dividers of this number, and we should return true or false in case if the sum of the dividers is equal to num. So problem is clear, and so let's check the constraints. So our num is from 1, and I guess that 1 is not related to the perfect numbers because of num could be divided by 1. Yeah, probably by 1, and we can't add the number itself. So let's add it as a condition first of all. So it's our first corner case, like num equal to 1, then return false. So let's say we are lucky guys. We kind of partially solved the problem. And what we should do as a next step, we should find the dividers. Okay, that's simple. I mean the sum of the dividers. Let's have some variable. We introduce it as a sum. Yeah, and we will do the for loop starting from int e equal to 2 because of the case with 1 we already handled. Yeah, let me initialize it with 1. Yeah, because of we will start from the 1 as a divider for any number, so we can divide 2 by 1, can divide so any number. Yeah, and we have the same the number itself as a result. So we don't need that. That's the like common operation, and so we may skip that. Let's start from 2. Let's use this as a condition, and so we are going to increase our loop variable. So, and if that's the case, we are going to have the following condition: if our num we are getting the modulus of the operation, like we are trying to divide and check if it's divisible or not. So it's possible to do through this operation, like we get the modulus. And so if that's the case, if we have this as a result, we are going to do like sum equal to sum plus I. So we calculated it, and we are going to return the condition that num equal to sum. Let's try to verify this solution. Let me run the tests. Okay, tests are fine, and let me print submit. So we successfully solved this easy problem. But here is the trick. When you successfully submit your own solution, that's the time to check if it could be done more optimal way. So let me open this article for you. I will add it as a part of this video description. And so as we can see, it's related to the divisors of the number. If that's the case, we are looking on the brute force solution. Like we have the some solution for checking any dividers for any number. And what is the complexity of this solution? I mean the brute force. That's the O to N, like ON solution, because of we starting from 1 and we are looping to N. So it's like complex, but let me scroll down. And so here we may take a look at the following property of the dividers. So like all the simplest divider of the each number situated at the distance which is equal to square root from the number itself. Like as you can see, the simplest dividers for 12 are about 1, 2, 3. Yeah. So like if that's the case, if we are correct, so we may check the pairs. So for example, for 36, yeah, we have the 1. Because of 1 we can divide 36 by 1 and receive the 36 as a result. After that we can divide by 2, and this is the 18. This is 3 and this is 12. 4 equal to 9 and 6 equal to 6. So we don't need this thing, but so other options are valid for us. I mean that we are starting looping from 1. And as you can see, that the complexity of this algorithm will be the root square from n. That's the much faster than O from n. Okay, and if that's the case, let's try to optimize our solution. But here is the trick, that so we also need to have some condition here, like to get the square root from our num. Is it correct? I'm not sure, because of we should apply the rounding for this strategy. Yeah, so like in case if we get the square root from the number, then we should apply the rounding. And I'm not sure if it will be a correct rounding in each case. And so as per my modest opinion, better to do that through the following way, like I multiply I. So this is like vice versa, not the square root, but just multiply by the same number. And so we have the good conditions here. Okay, we are looping from this sum. Also, I would like to introduce separate variable. Let's call it like another, or better to say like another divisor. And so if that's the case, we are going to do the next. So if this is true, then we are calculating this variable through the following condition. Like we are getting the second part of the set of the divisors for the number. Yeah, so like for example, if that's the let me comment here, if that's the 36, divide by 2, then we have 18. And vice versa, if we divide 36 by 18, we receive 2. Okay, so we have this thing here, and also I would like to add it there as another piece of our solution. Starting from 1, adding this guy, multiplying there, and return the result. Looks fine, and the condition the same. Let me run this solution. Okay, we have some mistake. That's normal. Let me run it one more time. Okay, the test case is passed, and let me submit it. Cool. So we have the faster solution for that one problem. And so I would say that you may try to practice this way to analyze any problem, to try to dive deep, and even the easy problems, sometimes highlighting the more complex things under the hood, in case if we are diving deep in the most popular problems. I'm about the leetcode blind 75. Okay, probably that's it for today. Thanks a lot for your attention and have a nice day. Bye.